Alright, I'm back. And we're going to take a look now this time at the change of angle. This is a harder one to do. We're still talking about Bilbo, but now we're taking a look how fast is the angle between the wall and the ladder changing at that moment. So, if I draw my picture again, whoops, careful, this is a terrible looking picture. Here we know A is still 26.5, B is still 14, and C is 30. But now I'm looking for the change in this angle right here. And I'm going to write down what I want to find. I'm looking for the change in angle. I write out what I'm trying to find. Okay? So write that out. Now I'm going to have to use a trig function. A trig function that explains all this. Now I'm going to want to use the hypotenuse because that's a constant. So it doesn't matter which trig function I use, but just one that involves my constant right here. The one I may choose to use maybe involves this b. So I might choose sine, mainly because it's an easier derivative to take. Sine of theta equals the opposite over the hypotenuse, c. But because we know c is a constant, I can replace that. B over 30. And that's going to make my derivative much easier to take because that's just really 1 over 30 times b. Taking the derivative, cosine of theta d theta dt equals 1 over 30 dB dt. Now I'm looking to solve for d theta dt. I know everything else. Now some of you guys are doing this. I gotta get the angle. What is the angle equal to? Yeah, you can find that angle, but remember, this is a ratio. Don't use trig to do that. We know. Don't use a calculator. We know what that is. Cosine is the adjacent over the hypotenuse. I know this is 26.5 over 30. You don't need a calculator to tell you that. You passed pre-calc. So let's keep moving on. So that's going to be multiplied by d theta dt equals 1 over 30 dB dt. And that we already knew from earlier is 0.5. And now I can actually solve this without even needing a calculator. I get 0.5 over 30 times it by 30 over 26.5. And I can simplify that. And we will get 0.5 divided by 30 times 30 divided by 26.5. And I get 0.0189, and the answer is always going to be in radians. We're calculus, radians per second. And it's positive, and it should be positive, because if I'm pulling the ladder away, that angle is getting bigger and bigger and bigger. So that's that change of angle problem. You want to know how to do this one. It's not hard to do. It's one of the easier ones, but people always make it really hard. Now the last one I want to take a look at with you guys today. The shadow problem. A lot of times students have a hard time with the shadow problem. So let's take a look at this, okay? Alright, sorry about that. Unfocused. Chewbacca. He stands 7 feet tall and can walk at a rate of 3 feet per second towards the light pole. Now the towards is going to mean something for us. 20 feet tall. What's the tip of his shadow moving when he's 3 feet from the base of the light? So I got to draw a picture. Here's the light pole. 20 feet tall. 20 feet. 3 feet from the wall is Chewbacca, the mighty Chewbacca. Roar! There's Chewbacca. He stands 7 feet tall. He's eaten way too many Ewoks, it looks like. Now when he walked past the light casts a beam. Like so. Well, I made this a little big, okay? So it's a little crazy. This is his shadow. That's his shadow. Okay? The shadow knows. I want to find out how fast the tip is moving, and that's this. That's the tip of the shadow. So I have to call it something, okay? Now here's a hint. If it changes, give it a variable. Does the distance between Chewbacca and the light change? Yes, I call that x. Whatever you want to call it. Is the length of the shadow, the distance between the light post and the tip of his shadow going to change? Yes, I call it y. And is his shadow going to change length? Yes, don't call a different variable. That's just going to be y minus x. And now I'm going to write down everything I know. what am I given? Okay, he can walk at a rate of 3 feet towards the light. That's giving me the change in x. See, that's the distance between Chewbacca and the light is x. So I know dx dt. And it's going to be negative 3 feet per second because he's heading towards the light. That distance is getting shorter. At what now? They give me x is also 3. But now they tell me this. At what rate is the tip of a shadow moving? Well, that's this distance y. I'm trying to find dy dt. That's what I want to find. So I got to come up with an equation, and I'm going to use similar triangles. Don't be a hero. Don't use Pythagorean theorem. I think you could get it with Pythagorean theorem, but it's way harder. Use similar triangles. 20 is to y. As Chewbacca's height, 7, is to the length of his shadow, y minus x. And I cross multiply. 20y minus 20x equals 7y. And I simplify, I get 13y equals 20x. Therefore, I'm going to have to go down here. I do apologize for that. Therefore, I get y equals 20 over 13x. Now remember, I'm trying to find dy dt. Now I can take the derivative. Do it equals 20 over 13 dx dt. Don't use x prime. You can do x prime at t or dx dt. Now, all I have to do now is plug in my dx dt, which is what they gave me. That's at negative 3. And I get this. Negative 60 over 13 feet per second. That's how fast the tip of his shadows is moving. Okay? And why is it negative? Because it's moving towards. So his shadow is moving towards, this point right here is moving towards the light, the same direction as Chewbacca. Now the next question says, at what rate is the length of his shadow moving when he's 3 feet from the base? That's easy. That's this length right here. The shadow nose is y minus x. I'm looking for its rate of change. The change in the shadow with respect to time, and that's going to become dy dt minus dx dt. And I know all of this stuff. Dy dt, just found it. Dx dt, negative 3, know that. And therefore, I can get the change in the shadow, length dt equals, now I'm going to be lazy on this one. I'm going to use, I don't need a calculator. I get negative 60 over 13 plus 39 over 13. And I don't know what that is. What's that? 20. Did I mess up? Oh, it's negative 60, not 16. There we go. Now I'm getting kind of lazy here, so sorry about that. Negative 60. Oops, sorry. Negative 60 plus 39, and I get negative 21 over 13 feet per second. So his shadow is shrinking at that rate. And notice we never had to use the 3 feet, so it really doesn't matter how far away he is from the light pole. The shadow's always going to shrink at the same rate. The shadow's always going to go at the same speed. Okay? All right. Look at these. Study these. Know these. Please. And I'll be here if you have any questions. Bye.